Hi everyone, and welcome to my video on using StatCrunch tutorial to perform a matched pairs or a hypothesis test and confidence interval regarding two dependent populations. So let's just observe for a moment. It says the following data represent the muzzle velocity of rounds fired from a 155 millimeter gun. Each round, two measurements of the velocity were recorded using two different measuring devices. So let's just observe here that this would be bullet 1, bullet 2, bullet 3, bullet 4, and so forth. And this A would be measuring device 1 and measuring device 2. So maybe they're just set up on opposite sides and the bullet is shot, and this thing, both of these measure at the same instant how fast that particular bullet is going. So notice that each bullet is undergoing two treatments. So each bullet, this bullet is a member of this population and a member of this population. So the reason why this thing is in a matched pairs is due to the same round was fired in every trial. The measurements A and B were taken by the same. The two measurements A and B are taken on the same round. All right, so pretty much that would be our answer. And let's see if we're right. Ta-ting. All right, so now when we go, as you learned in your reading, it's actually what you're going to do is you're going to take the differences. So usually it's population 1, A, and then minus population 2, B. So notice down here, the difference is here. So we take those differences and actually we compute the mean of those differences. So let's just note that the null hypothesis is always in the form that mu equals 0. This will always be the case. So notice up here using two different measuring devices. All right, so here we want to notice is there a difference in the measurement of the velocity? So a difference, we're not given bigger, we're not given greater, we just want to know if there is a difference. So we'll use the not equals. So this would formulate our null and alternative hypothesis, and let's just notice that it's always on the mean of the differences. Okay, so we got our green box, so we're off and running. So here we can just come over here and we need to get rid of that window, so we'll just go over to here, and since we're dealing with this data, so we'll open up our StatCrunch window, and I'm just going to come over here and see if we can't parallel the windows. Alright, so this is data set A right there, data set B. So we'll just go stat t-test 2, and this is paired, so you don't want two sample, you want the paired. So please make note of that. So we're going to choose paired and select the first column. So population 1 is here, population B is here. All right, and we have our null, and here we have our alternative. So we're good, so we just click compute. So here is our differences. So the mean of those differences, so you take 794.3, subtract 795.9, that gives you a difference. And so we have those 6 of them. So the mean is negative 0.688. Degrees of freedom is 5, n minus 1. So our t-test statistic, so we need to enter that in, round it to 2 decimal places, so negative 0.41. So we can come over here and negative 0.41. Check our answer, and ta-ting, we are good to go. So the p-value 0.6978, so we can go to 3, so 0.698. And check our answer. All right, and for a large p-value, we fail to reject. So basically we're saying that although there is a practical difference, notice that there's an average difference of negative 0.6833 between the two measuring devices. We're saying that there is not enough evidence. So basically what we're saying is that, yeah, both of these are doing what they're supposed to be doing, and that the only reason why we have a difference is just due to this innate random variability within our data set. So our conclusion says, do not reject. There is not sufficient evidence to conclude that there is a difference in the measuring between these two. So we'll go ahead and get our good job. Pat ourselves on the backs there. All right, so we're good to go with that one. And let's see, what is our, oh yeah, now we got to do our confidence interval. Ooh, I got a little antsy there. So let's go ahead and get our StatCrunch back up. Oops. And here we have to do a confidence interval. Got to do part D, can't leave them hanging. So stat, t-test, paired, column A, B. So what kind of confidence do we want? We want 99%. So again, we'll come down here, 0.99, and then compute. So we're going to round to 2 decimal places. Okay, so here we get negative 7.38. And our upper bound here is going to be 6.01. There we go. We got it. Okay. Let's see. It's like the Energizer Buddy. It just keeps on going, huh? Let's see. So it says to interpret. So we're going to say that 99%. Let's see. One could be 99% confident. So just kind of reading through these. It's not 1%, so it has to be parts. Which one of these? And we're not doing a confidence interval on the null hypothesis, nor are we, I don't know where 0.0 when that comes in. So it has to be part D here. Okay. All righty. All right. So I'm not going to get into all of this right here, but I think you kind of get the idea of how to perform the rest of this. So let's just go on to our next one. And we'll go ahead and do it here. All right, so in this one here we have I'll let you go ahead and take a few moments. You can pause the video and read the scenario if you so choose. Here basically we're asked to construct a box plot, so we can just go ahead and open up our data here. All right, and here we'll just go ahead and choose that, and we'll open this up in StatCrunch. Go ahead and close that out. Okay. Okay, so here we have our two data sets right here. All right, so we got to do some graphing here. So we're going to make a box plot. So we're going to use both of these. So I'm going to choose this one and then hold my command down and choose this one. I'd like to draw my boxes horizontally. I like that. And I think I got everything here. So this is our graph that our data set comes up with. So here we can go ahead and choose B. All right. So for this one, does there appear to be the difference? Why do we do these? Yes. So if we take a look here, notice here's the median for, let's get the right graph. The median's here and the median's here. So the question is, does there appear to be a difference in the medians? All right, so there you either think there is or you think there isn't. So yes, because the number of runs in the league appear to be higher. In League B appear to be higher. Well, if League B is to be higher, that would be up there, so that's not going to work. Yes, because in League A appear to have a higher median. So A is down here, and it does appear to have a higher median. We probably could think this. All right, so I'm just going to go ahead and choose menu option C here, and let's see what we get. All right, kind of cruising right along. So explain why the hypothesis may be used. Okay, so each sample is a simple random sample. Yep, we would hope so. Each sample size is small relative to the size of its population. So I think we're taking a look at baseball. And baseball has been around for a major long time. So each sample is obtained independently. So I would think that League A and League B are independent of one another. Each sample has the same sample size. That's not something that we necessarily have to have. Let's just kind of click over here. This is true, but it's asking why we're using two tests on independence. And with independent populations, League A and League B, we do not have to have the same sample size. All right. Let's see how we did. All right. Don't you love it when it goes that way? So we want to determine the null hypothesis. Well, the null hypothesis is on the mean, and it's always in the form mu sub A equals mu sub B. So make sure you choose the right parameters here. All right, but let's take a look. So determine that mu sub A. So we want to test whether the mean number of runs scored in League A is greater than League B. So here we'll go League A is greater than League B. I think that'll do it for us. Bravo! All right, so now we need to come over here and do our StatCrunch to get our test statistic and our p-values and all that other fun stuff. So we'll come over here, stat, t-test, to-sample, and here we have data. So we will choose with data. And here we'll choose League A, and for sample 2 we'll choose League B. Now again, as with the proportions, notice in this case, you know, StatCrunch is going to ask this way, but when we actually do, or I'm sorry, you know, this is one way of entering in, but notice over here, these are two exact same ways. So notice what we'll do is we'll bring the right-hand side over to the left by subtracting. So this says mu sub A minus mu sub B is equal to 0. So that's why we have our null hypothesis like that. And then again, if I bring mu sub B over here, notice it says mu sub A minus mu sub B is greater than 0. All right, so we'll need that. All right, and so we'll come over here, our standard error, our degrees of freedom, and here is our t-test statistic. So we want to run round to 2 decimal places, so this is 2.23. So we'll just enter in 2.23. So let's just observe that this tells us that the difference between the mean of A minus the mean of B. So notice what this is telling us. This test statistic is telling us that this difference, mu sub A minus mu sub B, is 2.23 standard deviations to the right of 0 in this case. Okay. So the question is that distance big enough away from 0, or, you know, we take a look at these, you know, to do our comparisons. That test statistic isn't going to make sense under this, but notice under this test statistic here, 2.23, is telling us that the difference in the two population means, or in this case the 2x bars, is 2.23 standard deviations above the mean. So the question is that far enough away from the means, from the null hypothesis, to say yes, there is a difference? So notice that based on our test statistic and doing our normal probability of, you know, x is greater than 2.23, under the assumption that mu1 minus mu2 is 0, so we go to 0, and so that gives us a p-value of 0.015. So we're going to round this. So this tells us that we have 0.02. All right, so we'll go ahead and check our answer. Oh. Isn't that not 0.02? Oh, 30. Ah, see? There you go. Got to read 1.5. We'll just go ahead and leave that oops in there just so you can get a chuckle. See, we didn't get the green box. Oh, it kind of freaked me out. Now we got the green box. So we are good to go. So with the small p-value, we will reject the null. Since we reject the null, we have to now choose the right choice. So C and D, we can kind of just process, eliminate those. So to reject the null, it says there's sufficient evidence at our level of significance, which is, what is it, 0.05 or whatever it was. Let's see, we have to come back up here. Well, 0.02 is really small, so it really doesn't matter what it is. So there's a level of there's a sufficient evidence at the level of significance to conclude that the game's played with the hitter results in more runs, or reject a null, there is not. Well, when we reject, there is. So we'll choose A, because that's the correct answer. All right, that's the correct interpretation. All right, so we'll go ahead now and perform our confidence interval. So I'll get rid of that. So stat, t-test. So notice here we're using the two sample because they're independent. You choose this one when they're dependent. So we want this one with data, and we're just going to, what is this? What is this? Are we getting crazy again? So stat, t-test, two sampled, sorry, we have with data. So here we'll select League A, and here we'll select League B, and here we'll check confidence, and we want 95. All right. So our lower limit, rounding to 3, make sure we read this correct this time. So this will be 0.181. Remember, this is on the difference of two means. So again, so 3.19. Oops, I think I said that wrong. 3.419. Okay. All right. So we get our green box. Yay, us. All right. So I hope you found this video to be helpful. I'll let you go ahead and, if you so choose, to finish that off. But mine is just to show you how to do the StatCrunch. So I'm out of here, and I will see you in the classroom. Adios.